Hello, everybody. So, a couple things to talk about tonight. Finish up that stuff we were doing the other day, to make sure you've seen all of the pieces that you'll need for this week's homework assignment. But again, my goal with the homework assignment was kind of introduce you to what GUIs are like when we're developing software. That's what we're doing here. And I wanted to start off with something and make sure to express that point very, very clearly. So first thing I wanted to look at was here on our syllabus. This is just somewhere where I know it's written. Oh, there it is. The actual name of this course. Right? This course isn't Python. Right? That's not the single name of this course. If we look at the name of the course, this is software development using Python. So what we're actually studying is software development. And then the using Python is the tool we're using to study that subject. A small distinction there, but it does lead into some other things. One of which is, I believe I've been programming for quite a while. I often tell this story. So back in the 1980s, we had a computer home in 1987. And what counted as basic usage of a computer back then counts as programming today. So there was that. Around summer of 1988, so well before any of y'all were born, I'm sure, there was suddenly a day, it was like they flipped the switch. And parents couldn't leave their children at home anymore. There were years people just left their kids at home without worry. They went to work and did stuff. Or ran to the store, ran some errands, especially in short runs. Kids would just be left at home. But then it really was like one day they just flipped the switch and kids couldn't be left at home alone anymore. So obviously nowadays that's not a big deal because there's all sorts of daycares and places for kids to go, and our society has generally adapted to that. That was 35 years ago, 34 years ago. Yeah, probably 35 years ago. I lived in a small town, so it probably took a year or two to get to that. But there wasn't daycares, and people weren't used to, people don't have a long list of friends they could call to keep an eye on their kids or something. So one of the things that was done was for summer school, when the kids didn't have anywhere to go, and parents all had to go to work and suddenly couldn't leave kids at home alone anymore. So for summer school, they just kept the school open, kept the buses running, and tried to make it interesting because they didn't want it to seem like a punishment. So there was lots of interesting things. My personal favorite was one of the teachers had a stop motion camera, like the claymation things. Actually, we did a bunch of claymation videos. That was definitely the most fun. But the music teacher's husband was a professional software developer. So to keep it interesting, he came in and had a bunch of kids gather up with Apple II machines and a couple old other things. I'm not sure what all they were. I know the school had some old Apple IIs that had been around for a few years at that point, and taught us some formal programming. So that was my first programming experience. In summer of 1992, I made my first thing that counted as a video game. I put quote marks around it. My first video game is it was a home computer in 1992, but a stick man bounced an orange circle and then would aim and throw that orange ball through a orange circle. It was hollow. So sort of a basketball game. That's what I called it. I was really, really proud of it. There was no Googling it in 1992 either. I just had to remember what I learned in 1988 and go through trial and error. So it was really just something to do to pass the time. In summer when I was 14, I was too young to drive and go anywhere. And stuck on a farm that wasn't a farm anymore, so it was just miles and miles and miles away from any place. So I've been programming for a long time. From around 2010, when I had to change careers, went to school, dropped out, started another school, dropped out, and back and forth, ended up in audio engineering. But around 2010 or so, the software had replaced the things people were most likely to mess up. And at that point, well, if used car guys aren't paying a sound guy to make a commercial every week, it's not a job. It's a lottery ticket. Like I still have all the microphones and stuff I can record a band, but music's a lottery ticket. If used car guys aren't making a commercial every week, it's not a job. So that's when I came back to school and had no computers for a long time. And so I go, I need some paperwork because I can't get a job with this thing that I've been doing for decades. Changed paths along the way and decided to be a teacher. I started tutoring, but I've been around computers for quite a while. I don't know everybody's exact age, but in general, I've been using computers for longer than people in my classes these days have been alive. So, all that, went through a bunch of classes about computers and programming and stuff. And this word here that I just highlighted, software. That's the goal, right? Not programming stuff, but just little useful scripts to make my life easier, or a few random things over the years. But once it was actually software, it was like, okay, I'm excited. I'm ready to make software now. So did what I studied in the class, and then I hit a wall. Because all we did in the class was write those scripts. We'd open up text editors or text editors and stuff and just put in some instructions and run it. And that was all any of my classes ever covered. Never went over what to do after the software is done. Right? What's an extreme example of this? Okay, for example, if you want to use Photoshop, do you contact Adobe and then they send you a text file written in C++? That's what Photoshop's written in. Do they send you a text file of C++ code that you then compile and run? That seems to be all that classrooms cover. So that's one of the reasons I was super excited to do this, even though I studied to be a math teacher. When an opportunity for software development came up, I was super excited because I was like, yes. Because when I finished studying software, making software, and wanted to make my own, I suddenly hit a wall. And the process of what to do after writing the scripts was way, way harder than it needed to be. And it was never mentioned in a single time that I studied it. Because I mentioned the first one, but there were other things along the way. Back then, when I was on my way through school, it was just schools were starting to put together computer labs. And if any teacher or secretary or anybody that worked for the school system knew anything about computers, they were the computer teacher that semester. So it was a lot of scattered knowledge put together. So a lot of things over the years, and then formal training, 2010 to 2014-ish. I got a couple degrees and took a bunch of extra classes just because I thought they sounded interesting. Anthropology, archaeology, a whole bunch of that stuff. So I stretched it out, not really sure what I was doing anyway. But a lot of studying software. And afterwards, all I had ever seen in any type of training, and then same thing in tutorials for looking it up or and all that stuff, just covered, okay, write the script. Yeah, here's a Python script. It runs. But if you're on a piece of software you're really proud of and want to release it, you're not going to give that Python script to somebody, right? And even if you do, they're not going to know what to do with it. You'll have to probably sit there and explicitly walk them through the steps. That's where things like installers come in. When we go to install a piece of software, like Python. A programming language is a piece of software. So when we go to download it, or any piece of software, we click a button like this, so this recognizes it's on a Windows machine. So we probably want something like that too, right? After we get it finished and we give people a link for it, we want to make sure the software knows what machine they're on so they can download the correct version. That way they don't have to try to figure out which version of our software they need. But that's a more detailed version. And then we download this. In this case, an exe file. The .exe installers, the executable style installers, those are the ones that pop up a wizard. Y'all have seen them. A little wizard dialog box pops up, and keep clicking next, agree to some terms, and make some choices along the way, and keep hitting next, and then finally hit finish. The big alternative on Windows is the MSI installer, a Microsoft installer. And that's the one where it just downloads and you click it and it runs. And you might see a meter, but you don't have to keep hitting next and choosing options. You just hit it and it runs and this is done. Never saw how to make those. Those are installers, those are important things. There's a lot in that automated process. We're going to make an installer in the semester, either an exe installer or an MSI installer. Either way, it's a big file of command terminal instructions. And I always like, when we get there, you will be surprised at how long it takes the computer to write that text file. It's not hard, but there's a lot to it. And when I finished my software development courses, that had never even been mentioned, and other things. So that's why I like to work it in along the way. So one of the things that all of those installers will need, I mentioned pip and Anaconda to get started, because those are also installers. Those are how we install new things and customize our installation of the Python programming language. So that, and then those executable installers, once a full piece of software is finished, those things need certain items. Right? Like if you make a piece of software you're really proud of and want to share it with your friend, and you're like, yeah, I got Python on my computer, I can do that. So you send them the files. Even if you send them the files, do they have the right version of Python? Because I just mentioned that Python, the programming language, can be customized. There's different options. The easiest way is, if y'all have ever heard of Blender, it's very popular 3D modeling software. What they do is they used to have a big complicated thing that checked it, and it got more and more complicated. So anymore, they just include their version of Python. They install another version of Python, whether you have one or not, so that they know you have the correct version of Python on to run. Like the other day, we saw TQDM. If your software needs that TQDM module, and you share it with your friend, and they don't have that TQDM module, it's going to crash. So that's what's called dependencies. A good place to start researching that is right on GitHub, because GitHub is, how do I do that? I don't need to search for GitHub. I know what the address of GitHub is. There we go. GitHub is a tool that software developers use. If I do this. I don't know my GitHub password, so maybe I should go to the other computer. I'm going to the other computer because I'm pretty sure that I will have to get an email and click the forgot password button and all that stuff. I go to GitHub if I try to log in there. So I'm going to go to a computer that does know my GitHub password. Sorry about the change. Oh yeah, so GitHub is a tool, repository. CNET is another very, very, very popular one you may have heard of. But there's lots of repositories out there. So they do certain things, like they're set up for this. Here's one. Most of my stuff when it's ready for release, I move it off GitHub. GitHub is where the working versions are. But this is I got tired of spreadsheets, so I made some custom software to do double entry accounting. There are pictures here. Yeah, keep track of my own expenses and something that looks like they'll check with ledgers, and it automatically handles the double entry accounting standards and the primary displays like the regular accounting financial statements. So I wanted that. So I made my own, but that's not a release thing. That's just something for my own needs. So on GitHub, there is this actual release. And y'all have probably seen that before. Heard about some software and go to get it, and turns out you get it right from GitHub. It's a place where we can do that. And yeah, so this one has exe installer for Windows, a PKG installer for Mac, and the same thing would apply. It needs to know what other libraries to run. So like this particular one's in Java. So it needs at least a Java 11, I think, 11 or higher. So when one of these installers runs, I did a .dev file. That's an installer for Linux, but Linux users would never use an installer. I always just make those so that Linux users know that I did test on a Linux system. Linux users want the source code. But all of those, when it goes to install on a computer, it needs to make sure the proper version of Java is running. And some other things, not just Java, but some custom libraries that I used when I built that with Java. So it needs to check and make sure that the right setup's there. And that's what the manifest does. It's a list of, well, the traditional use, the captain's manifest is a list of what's on his boat or her boat, what's on their boat, and the reason why it is there. So the manifest is the same thing. It's like, what is in this piece of software and why is it there? So that when we go make an installer, whether one of these aftermarket ones for an end user or something for PIP or Anaconda that another software developer will use, we need to have a manifest to tell them about that. And another little nice thing on GitHub here is GitHub, that's a common thing. And apparently I wasn't the only person that, after finishing a bunch of classes that included programming and stuff, hit that wall when I tried to release my first, do a first formal release. It's like, okay, the software's ready, what do I do now? And it was way, way harder to learn that than it should have been. It is a subtle note that can be made. It is a few small points to make along the way. So I wanted to include that. That's why I was so excited when the opportunity to teach software development showed up, so I could show people these things. So it's a common thing. So I just went into one of my repositories. The one for our class, it has a manifest on it. So it does not have the link I'm looking for. So I went into another one of my repositories that does not have a manifest on it. Again, this is just some personal stuff on there. And on the Insights tab, yeah, this is for a Chromebook. I love how Chromebooks can be factory reset with one click. So I just have some Linux shell files so that I factory reset, edit, and change it to, like, say, an engineering one with CAD software, and a full stack one with virtual server and all the PHP and run PHP, and then text editors and Python and Java and JavaScript, all the languages and everything, and all the stuff I need to test to do that. So I just wipe the Chromebook and run a quick script to set up really quick. That's what this one is. So it doesn't have a manifest. That's definitely a personal use thing. So if you go to the Insights tab, there's a thing here called Dependency Graph. If you click on that tab, you'll see this says no manifest files found. So it can't tell us anything about the dependencies of the scripts in this repository yet. But there's a link here that tells us what sort of files it's looking for. So if we scroll through here and check for a manifest, so here's our language. We want to look through here and find Python. Okay, looks like we got 2 Python options. Either poetry or pip, and hopefully by now you recognize pip. Poetry is the custom one. It's pretty nice. It has some advantages. I don't know if it has any big advantages, but Anaconda will use the same thing as pip. That's why you've probably heard of Anaconda, but don't see it on the list. Because anything about Anaconda will look for requirements about pip. But here's the 2 types of manifest files that have to be there. Requirements.txt, this is the one I asked for because it's a whole lot easier. So for example, we're doing something in TK package. The TK interface package, and unless somebody else had a different idea tonight, I was going to use something in the updated TK interface package where they updated it in 2001, 2002, somewhere around there. So create a text file, go to save it, and in the delete folder, I'll save this with the name requirements.txt. And that's it. That'll be it for this part of the manifest. We go with this time. There's several parts of the manifest. So some languages are very complicated, but following that thing of trying to make everything as easy as possible in Python, they did the requirements file. So if we did like TQDM, what version was that? Let me look that up real quick. If we did use our TQDM thing, we have a version number here. So you can see they have sort of some fancy looking stuff here. I don't see it. I can check. So, oh yeah. Python -m pip. I think that was on the last computer, so I couldn't do this. Install TQDM. Might as well install it, that's a useful thing. So there where it ran that. It checked to see what else it needed. There was something. Oh, the requirements already met. So it looked to see what it needed. All the requirements were met. That's what it does. So we need that file. So I'm going to use the pip module and type in the freeze command. So here is everything that I have installed that is not part of the default Python installation. And these lines right here are what go in the requirements.txt file if we need them. So if we wanted to use TQDM, we'll just copy this right here. Copy. Oh, whoops. I'm in a bash shell. Right click, copy, bring that over there and paste. And then that would be the requirements file. Oh, doesn't hurt to have a library. That would be the requirements file for something that uses TQDM. But that's going to be updated. If we want our software to be around for a while, we might want to switch that to greater than or equal to. So if they update it, somebody has a newer version, it'll probably be okay too. So we can do equal to, less than if a feature gets deprecated, so it has to be before a certain version. And then pip or your executable installers or your MSI installers or your package installers on a Mac, image installers on a Mac, any of Debian installers on the Linux, any of your installer files will check that manifest and compare that to what's on the machine to make sure the software will run on it. So that's why the manifest is important. And all the way through school, and that never got mentioned in mine. Especially if it's something as easy as this, right? If everything you use came from the default installation of Python, that's it right there. And it does have to be that exactly. Python, the language itself, is going to look for a file called requirements.txt and run it. So you'll get an error message if it's not there. But there are other parts of a manifest not included. So let me go ahead and show another one that's really easy. We also need something that goes with our language. We also need one called __ init__.py. So we also need this script. This script is a Python script that just has a list. That's the only thing that goes in it. Has a specific name that we will see when we look at recursion. But this file, it either is completely blank or it has a Python list. And that Python list is what is included in the module. So if the file is completely blank, then everything that we wrote in that module will be included. If there are some functions or objects that are for background use only, that we don't want the user to have access to, we have to write out the list and leave them off of the list. So the list has everything that's included, and if the file is completely empty, everything in the module will be, everything in that folder will get included. The library or the package or whatever you want to call it. It's different terms that kind of mean the same thing. They switch language to language, and since we often work in multiple languages, most programmers are used to using those words interchangeably as we switch between languages. So we use different vocabulary in different languages. So this one, you'll just get a warning if it's not included. So when you do an installer, if you didn't have an init.py script, you would get a warning to say that that's missing. This one will crash and the installer will fail if that's missing. But it's a really, really easy thing to turn in. So that's what the requirement in the homework is. Just create an empty text file called requirements.txt. Please don't change the name. That is hard coded in there. It's hard coded into the Python language to look for that file. Unless another name is there. But that's the official one. That's what we're supposed to look for. This one is JetBrains. They're a very popular company that make IDEs. This is where we have it. Yeah, this has the pip file.lock. It goes in TOML notation. Yeah, which looks like this. So it's a whole lot easier just to write that little, either a blank file or a comparison, because the second choice from the people who actually make the Python programming language is a whole lot more to type. We have to have things in angle brackets. You notice that one up at the top has nested, has the square brackets nested inside of square brackets, and then a whole bunch of information. And this one cannot be blank. Let me go back to Gap. Actually, if I do this. There we go. So, yeah, I decided to go with the easy one, ask for the requirements.txt file. And another part of the manifest is that init.py. So if everything that you imported to your module is part of the default installation of Python, your requirements.txt file will be blank. And if you're going to use every function in your module or every class in that module, then your init.py script will be blank. So a manifest in Python is that easy, but those files have to be there when we get to installers. So that's why I wanted to, that's the reason why they're being included. Somebody had made the comment that they were having trouble finding it. And I thought you actually probably did find stuff on it and just thought you were looking at the wrong thing. Because I used the term dependencies. So if you look up dependencies, you would have come across this. A file describing all the math notation, or other references might look even more complicated than this. When you see the math, and it might look like a mess, but it's not really a mess. It's not really as bad as the notation makes it seem. We run through a function that converts everything to a numerical list. So if there's stuff in the requirements like txt file, it puts a number on it. It turns them into an ordered list. That first line sure is a complicated way to write that. Well, actually, the first two lists are a way to write that. And then we come down here and we look at everything on that list and check what's then check what's on that list with the stuff that is already installed in the Python programming language. It sure looks like a mess when we see it in mathematical notation, right? So if you looked around and came across some really, really messy math, you might have found the right thing, but didn't realize that's what you were looking at, because that's the theory behind it. There's some other further reading here that you can look into, but so for all your languages, this page on GitHub, which open a repository without a manifest, go to insights and then dependency graph, and it will tell you what the official manifest file type for that language is, at least on the most popular ones. And I've seen some different ones. So I think this page might change depending on the languages you work in. But we just talked about the one for Python, and Python's an easy language to work in. It's a little bit slower than some of our other languages, but now that that doesn't matter like it did 25 years ago, most programmers go with the easy way. Even for like embedded systems, we're finally getting to the point that time critical embedded systems can be done with the ease of Python. The machines are getting so fast that slower is no longer an issue. So that's what the manifest is and it's about. So hopefully you see there, that's a really, really easy requirement to meet, because for most of the stuff in the class, the homework assignments, you're probably not going to import a module that's not in the Python language itself, which means you're going to turn in an empty file called requirement and just give it that specific name. And if you want to, just to start forming the habit, since this is a software development course using Python, might as well get in the habit of building the whole manifest. And you're probably going to use Python. Go ahead and include that init file too, because especially for class, everything you write for a homework assignment probably needs to be turned into that homework assignment, right? So you are going to include every single thing in the Python scripts you write that you when you send them to me, which means that init.py script will be an empty file. They'll just have that specific name so the programming language can find it. But that's what that's about. Part of the thing where, yeah, when I finished all my courses, I made a piece of software. I was super proud of it. It ran great. Tested it on lots of different systems. It was working all over the place. But then, bam, what do I do with it? It was never addressed in any of my computer classes about what to do once we finish that. So I like to include that. Does anybody have any questions about that manifest thing? I mentioned that took longer than I meant for it to. But tonight's example, this class stretches out for 16 weeks. And that is one of the things that I feel is kind of important. That's why I was so excited when opportunities to teach software development showed up. I was like, yes, I have a number of ideas that I feel very strongly should have been included in some of the classes I took, because I hit that wall about what to do after finishing. The classes only covered, well, how to make the stuff, then not what to do with it. Okay, so if there's no questions, I want to jump back into the GUI stuff. But first off, just a look at thing for something we did the other day. So I'm going to log on the other day. I was working on the PC, right? Yeah, I think I was working on the I was working on the PC the other day. So I'm going to jump on the Mac here. And I probably need those files. Nope. So make a folder called Get Stuff. Just using that tool, you'll have seen this a couple times. Going to Get Stuff. The Git command, init for initialize, dot for the current folder. And now Git remote working, add in an origin of github.com branches dash Chris 5 repository has, or domain has a repository called SDEV20-spring2022.git. Now I can do git full origin main. Okay. Oh, wait, on the Mac. I've actually hit the X. Now if I go in Spider. The other day we ran that. We wrote Python code with the TK interface package, ran it on a PC, and it looked like it belonged on a PC. Perhaps a little out of date on a PC, but it still fit with a PC. So now I'm going to go over here and open the exact same code on my Mac. There's one from the other day. There you go. I'm going to make a slight change. I did this on purpose the other day to express this change. So the other day, instead of copying those other files we needed over, I just put their address in there. But now I switched to a different machine. So the address of those files has changed. Sort of. The address changed overall, but open up Finder here and go in this folder. So here's the other day's thing. If I hit command up, if I go up a level, and right over here is the folder init. And that's the same way it was when we wrote that code there on the other machine. The relative address between those files, our file and the ones we need, is the same. Up one level, over to the PyOffice folder and into it. So instead of absolute addressing, since one of the most powerful things about Python is the cross-platform issue, we should use we want to use relative addressing here. For one, that's a Windows address. That wouldn't even work on the MacBook here. That would just crash immediately. The Mac would be like, why is there backslashes all over the place? Backslash doesn't mean anything to a Unix operating system. So we can also use relative addressing. So to go up a level is dot dot. Dot dot means go up a level. And then slash means go into a folder. You already knew that part. So that's the same on any machine, right? So whenever you do that, insert an address to pull in the other files, make sure you do it in a cross-platform way. Because we put in that instruction, but everything else is pure Python, which is already cross-platform. So now with that little change, I can hit save and run this. Oh, whoops. I erased the P as well. If y'all see little typos like that, feel free to let me know. Okay, there we go. So I can run this. So notice it doesn't look like it did the other day. All what we really did was the menu up at the top, which we did on a Windows machine. And minimize everything else. It'd be nice if we had the shake feature on Mac like we do on Windows. That's a great thing there on screen. But that looks like a Mac GUI now, right? Our buttons are over on the other top corner. And furthermore, our menu is up here. Not connected to the window. So we can move that the window around and the menu stays separately. The main menu stays separately. That is because our software here the TK interface package is what we call native software. We'll try a different mark. It's a native GUI package. That means it's going to ask the operating system what a window should look like. Whether we said GUI.config main menu in our example the other day, that doesn't include instructions on what it's supposed to look like. The instructions in the background there are go ask the operating system what a main menu is supposed to look like. So that way it looks appropriate for all of our different systems. So TK is native. That's a really nice thing. So whatever system we run it on, when we run that same code on another system, as long as we're careful to remember our part, to make our part cross-platform, such as using relative addressing to go to a different folder instead of absolute addressing, then it's fully cross-platform. It will look appropriate on different systems. There are external packages that we can install and then use with our version of Python, and then put on a requirements.txt file and the requirements.txt file so that the installer knows to make sure they're there before we run it on somebody else's computer that are not native. I like WX Python. That's my favorite one to use. It is native, just like the TK package. But that's a very important word, and that's going to be in all your programming languages. You'll learn other ones and put GUIs together. Native means that it's going to look appropriate on whatever system you run it on. So back to the PC and next couple steps in this. Right. So far, I've been really happy with the Windows 11. It's only a couple days into it. It was a rush, though. This has twice as much memory as my previous laptop. This folds doubling the memory, so I haven't had a bit of trouble narrowing down what it is about Windows 11 and what parts might be just because there's twice as much RAM. So twice as much RAM and more speed, bigger numbers all around. But in general, I've been really happy with Windows 11 for those who haven't used it yet. All the stuff. It's consistent. everything changed, but it's changed in the same way Windows always does every few years. So the other day we set up a main menu to call this function. It was already pre-built, and that's what your homework assignment is. You use some pre-built functions, and I gave you a couple more that weren't included in module 1, just to show the repetitive tediousness of front-end development. That's often left out of books, so I wanted to make sure y'all got a sense of that and how to do it. This is very, very important to start looking for patterns you can copy and paste and minimize the amount you type, because there's going to be a lot of just repetitiveness. So it's usually easy things to program because we can, well, like here, write our function elsewhere, test it, make sure it works, and then just bring it in so that a graphic interface sits on top of it. So they're almost fully separate. Makes testing easy, and then the interface is just a lot of tedious repetition. Like your homework assignment is to make a menu, make all these things. So in the menu, there's 5 of them in there, so you'll just make one of them, get it working, and then make 4 copies of it, or 5 copies, however many there were there. Make a bunch of copies of it, and then the same thing with buttons. We'll make one, get that button working, then make 4 more copies of it that are slightly different, and then make slight changes to them. So there's a whole lot of copy and paste stuff. I want to change this a little bit. I'm going to make I'm start laying out the image tonight. I think some of this example might stretch out into next Tuesday, but yeah, the normal way I go through an example, talking slowly and probably going down a rabbit hole or 2 along the way. So just a quick reminder about the thing I'm asking for. One of the standard images, what I call traditional is the easiest one in TK. So we have a bunch of menus up here, usually file, edit, and view. But for your homework assignment, the shape menu will be enough, and then put your buttons in there so that those pop down and have menus. There are more modern versions of them. And then right below that, we'll have a toolbar with buttons that do the same thing as that menu. We don't write more functions. It's just another way to call the same function. Then we'll have like some sort of primary input output area where we can right click on it and get another little menu pop up. That again does the same thing as the menu up here and the buttons here and whatever the primary IO is for. There's lots of ways to do the same thing. And then down at the bottom, a status bar to indicate what's going on. That way when a user opens our piece of software, they know what to do with it already. This looks like many other pieces of software they've used. So we saw that. It's the next thing. We need a toolbar. I'm going to go ahead and do the layout next. So there's an area for the toolbar, an area for the primary input output, and then an area for the status bar. Not any of the widgets for them, just the areas where they're going to go. The containers that are going to hold our widgets and keep them organized is separate, which in the TK package, those are called frames, like a window frame. Yeah, the name makes a lot of sense. We're making a window, and we need to split that up with some window frames to organize it. So I'll call it TV main. So again, with Hungarian notation, that's the convention I like to use, which is a very common one. Variables get camel case, methods get Pascal case, And anything that shows on the screen gets on the other end of it. And then we can reuse those useful terms, and it makes it a lot easier to tell at a glance what goes with what, as things get more complicated than what our classroom example is going to be here. So that's going to be a new TK dot frame. And with the frame, that's just a container. So all we really need about it with it is, once again, with the tree we talked about the other day, what is the parent node on the tree? There's always some root up top, and then off that root we'll have branches coming down. We have other nodes and different branches off that. I think we have an entire module dedicated to trees. So we're going to talk about trees. It's a very common structure. There are a lot of advantages of the different types of trees we have. So we'll talk about those in detail coming up soon. Very common thing in computers. But whenever we make something new in TK, we have to say, what's the parent of this? Where does it connect in our tree? So our frame's going to go on the main GUI. The other thing we might want is some sort of border around it. Like here in the picture, I drew box lines to identify different parts, but we can put different borders. That's an easy thing to check. But one thing about borders that I used to forget all the time is you do need to put a size before you put a style on your border. Because by default, the size of the border is 0. So if you go try to style something of size 0, there's nothing to see. The computer applies the style, but the size of it is 0, so we can't see anything. And then the attribute relief has a few things we can put in there. TK dot raised and ridge are a couple. Groove. You just want to check the list. And you can either do it as a constant like this, the TK module dot groove constant, or put it in as a string. So I'll just make this one groove. And TK will interpret that string. It'll come down a little. So then maybe a comment here. Buttons for toolbar. And when I put together a GUI, since what we saw that morning the other day, overly complex, difficult to debug code. So organization goes a long way. I try to match the organization of how it's going to look. We do the main menu first, then come down to the toolbar, then all the primary stuff, and then the status bar, and then on TK I put then after everything has been created, put them all in at once. So I try to put my code in the same order, roughly the same order it's going to appear on the screen to help keep it organized and cut down on some of that complex, difficult to debug issue that is common in event-driven programming. So that'll be our main. And I'm going to make the primary input output. I've never really settled on a good name for this one. The IO primary input output area is just the latest one. I only thought of that a couple months ago. Like, that's a good name for that. I might use that for a while. If you say primary input output area of a GUI, most people know what section of the GUI you're talking about. The working area. Might be a good name for it. FRM working or working area, or just call it working area. And comment stuff for the primary input output GUI area, GUI working area. Still trying to decide on a good name for that, but toolbar and status bar, those definitely have names. So for the status bar, I'm gonna call it SD. So status bar main is a tk.frame that goes in the GUI. Again, I'll give it some size of border and a relief. Relief. Try to spell relief correctly. Sunken's another one. You can try a list. When you see the whole list, you'll be like, oh, I probably could have guessed those names with only 5 or 6 extra guesses. Raised, ridge, a groove, sunken in, flat. Yeah, an easy list to find. It's actually in that somewhere in that PDF I sent. But I didn't talk for a long time, so let's jump ahead to the doing stuff. Y'all know how to put things in the search bar in Google for those finer details. So we need to put that on here. What I like to do is we have different ways to put things in. So config, pack. We also have a grid where we can lay things out by rows and columns and make it a nice table-like structure, table-like positioning on the screen with rows and columns, or place, which is also a table-like structure on table-like structure, only it's pixels, not rows and columns. Personally, I like grid. That way I don't have to worry about the sizes and just let the computer handle the sizing. But either way it works. And what I like to do is those main containers are toolbar container that the buttons are going to go in. The primary input output, the status bar, the text and meters and quick access buttons will go in. I like to put those containers in with the pack method. That way they just go in stacked top to bottom. And then the things inside there, I'll use grid. So to put those on there, we just need the name of them. So like the main toolbar, tb.main, and pack it in there. And this one we want to stretch all the way across our GUI, right? So to do that, we set fill equal to both. So by default, pack will try to center it. And then we can fill it to the left or fill it to the right or fill it both ways. Same thing with our status bar. It's going to be down at the bottom. So our main status bar, we're going to pack that in. And again, we want to fill it both ways. But in between them, sort of the same thing. We're going to pack it in there, right in between them. Fill both ways to go horizontally, and expand to go vertically. This computer. I'm done with the Mac. I should turn that away. I walk over here and the IDE is being screencast onto the other computer. I confused for a second. So our IO primary area will get packed in here. The fill both and expand equal to true. A lot of your reference material, you see that expand equal to 1, but that's a true or false is what it's actually looking for. 1 can just be used as true in a lot of situations. Let's run this, see what that looks like. It opened in the back. So see something. It's looking a little off. Oh, because those things are packed inside there. It's kind of hard to see anything here yet. I think I need to put something in each one. So then for loading things in, like our label and there it is. Our label and instructions, instead of going right to the GUI, they're going to go in that container we just set up. In this case, oops. Why did my cursor move? There it is. In this case, instead of the GUI, we want to put it in the primary I/O area. And then personally, what I like to do is pack in the containers so that they just go top to bottom, and then stretch them out as needed, and then do a grid for the stuff that goes in a container. And for a grid, we need to know what row it is, like row equals 0, column equals 0. Then the padding from last time, same thing here, row, oops, undo something there. Put that in row 0, column 1. Oh, actually I went the other way. Go down, row 1, column 0. That way it's underneath it. Oh. And that word needs to be changed to grid. I have no idea where those extra letters came from. I think that came from the new keyboard. What was that? Crash all those. There we go. Now with the new console, run that. So you see it left some space up above. Looks like something should go in there. And that's where our toolbar buttons will go. So I'll put something in one of those. And I was expecting to see the borders already, so I think I might have got a typo somewhere. But maybe I do need to see something. So for buttons on Hungarian notation, I tend to just use BTN. So button payroll. And that way it matches this useful name that we kind of already used. Oh, gross pay. That's what I should call the button. Button gross pay equals pk.button with, that's going to go in our main toolbar. And that's probably enough. We could do text equals something, but especially for toolbar buttons, I would prefer to use an image. So I guess I need to draw an image. I haven't checked this on nice. They still have traditional paint. Oh, it looks like this has been upgraded. I need an image for my button. So I'm just going to draw a quick placeholder. Oh, there it is. I'll come down about the size of button I want. Zoom stuff's in my way, so I can't see the size. 65 by 60 by 60, that'll work. Let's see. It's kind of hard to tell what's what there. We have a calligraphy pen and just make a dollar sign for the button here. That'll work. gross stock. Yeah, that's for the gross pay button, so I'm just gonna call it gross and make sure it's ping file. Looks like they updated paint, but I'm sure it still does ping files, but. And now to import that, we need to bring in that file and read in that file and put that in a widget that works with PK. So we can do IMG for image and match those others. Yeah, I'll call that gross pay. Be more specific. That way you can see all those words line up. And by using different conventions, we can even have a gross pay variable. And we have that same useful name over and over and over again, just by writing it in useful convention. So to get an image, that's a photo image, PK photo image, and then what is the file name? And if it's somewhere else, make sure you just have the whole address of how to find it. Preferably relative addressing, so we can go get it. Gross.png. So now instead of text on our button, we want the image attribute, I think. I'm suddenly drawing a blank. Oh, yes. Particular text recognized image as a correct thing in that spot. So our image attribute equals that IMG gross pay variable. Your picture might be bigger, so I'm going to do this. Image gross pay dots equals. So this is our widgets are objects. So there's a lot of methods built into objects. We saw that in the previous module and in a prereq for this course. So we see the same things over and over again and develop a better understanding of them. That's my school seems to stretch on at times. So we can see the stuff repeatedly and use it in different situations to get an understanding of it. So that photo image thing has some stuff we can use. Subsample is what we use to make it smaller. So we want to subsample this image, and then the number we pass in there, we divide by. So if you have a big image and want to make it smaller, you'll put a whole number in there so we can divide by it. But if you have a small image and want to make it bigger, put a fractional number in there, a fraction or a floating point number, something less than 1, so that when we divide by that fraction, our image gets bigger. So subsample divides by a number. So originally it was 60, somewhere near 64, 64. So I'm going to divide it by 2, so it should be somewhere near a 32, 32 image now. So I'll save that. And so got an image, which I like images on buttons instead of words. Made that smaller, or made that an appropriate size. So all in all, it usually works better just to resize the image to the size you want beforehand and adjust the image size in image editing software. That is usually a better idea. Or ask the art department for the correct size image. We load that in there. So now we can go check that. Because our general rule of thumb for testing still applies. You want to run a test every chance you can. Especially if you can run a test every line, that seems like a lot of checking. But at those times when we can run a test after every line of code, if something goes wrong, we know exactly what line that happened on. We didn't have to think about it, right? We've only written one line of code since the last test. There's only one spot where the error could be. So we'll go down here with this load stuff in. So there's our main content. So then in the toolbar, that button gross pay, I'm throwing it in as a grid. Row equal 0, column equals 0, and I guess some padding, 5 pixels of padding each way. That sounds good. Add X 5 pixels and add Y 5 pixels. And when you first glance at that, it might look like, you might think there seems like a confusion there. We did row 0, column 0 twice. But remember where the parent containers are. So on the button, it's row 0, column 0 of our pad pane. But on those, that label that temporary label that's on there, it's row 0, column 0 of the primary and out section. So it is, oops, Control S. It is a different one each time. Uh-oh, looks like you couldn't find the picture for some reason. Oh, what's that? Got that. Did I name it incorrectly? Let's check. Oh, yeah. You know what? Oh. Gross check properties .png. I'm gonna restart the kernel and try this. Okay, where did that? Oh, sorry. File equals that. It has been many years since the first time I saw the PK package. I still make that mistake all the time. The name of the file is not the first parameter. All of the attributes are optional. There are default ones, but the name of the file is not the first one, so you have to explicitly state what parameter you're filling with that. Otherwise, we won't be able to fill it. Oh, and notice now that there's something there, we get that little groove around it to kind of signal out where the toolbar is. Usually I do that raised, the toolbar raised, and the status bar sunk. So we need something in the status bar so we can see that. Which for a label will work. We'll just throw some text on there. Label status equals tk.label. It's going to go in our main status bar. This is not on the one that's on the screen right now, but you probably noticed that most status bars anymore have at least 3 defined sections. We have a left, middle, and right. So you might want to do that on your status bar, do 3 different ones so you can give different information in each one. So it goes in the status bar main. Text is going to be status. I'll put ready and some dots. And while I'm at it, all that's going to do is just throw up some text saying what we did, right? So if we click that gross pay button with the employee Bob, it'll say found Bob's gross pay. We switch to the employee Becky and click that button on the status bar to say found Becky's gross pay. So not the output, but just the status of what the software is doing. Also very common to hover over things. But since we're doing that, we'll probably want a method that we can call over and over and over again to update our status bar every time there's a change. Which we're in event-driven programming, so event goes first, unless we use class notation, in which case self goes first. And then event is the first open parameter after self. Because the interpreter will pass those in. The interpreter will pass in self, and then the operating system will pass in the events. And all this needs to do is that status label, it has a text attribute in it. So we're going to change that to the word status plus some string that we'll pass in, and I'll just call that status in camel case. So there's all the different cases. The word status is the most convenient thing to use, the most descriptive thing to use there. And I was able to use it over and over and over again by changing notation. Camel case for variables, Pascal case for the methods, and Hungarian notation for the part that actually shows on the screen. And that's pretty much what your status bar is always going to be, or that's what your status bar is going to be for this class. You will expand that place to write stuff. Don't know what a status bar looks like. You see the one down here. It says where the cursor's at, what the encoding is. The end of line status. I'm on a Windows machine, so it gets a carriage return and a line feed. \R/\n, not just a backslash, not just \n. If I ever need to read and adjust this file. So might need to go change that. Have permission to read and write this file. Something about memory usage. Now we just need to throw that status bar up on here. LBL status grid row equals 0, column equals 0. I think the last one was still running. Stop the previous run. And I'll go ahead and reset the kernel too. Sometimes with images, when you're testing it, your IDE will try to cache that image. CACHE, the storage cache, not the money cache. They'll try to cache those images. So if your IDE caches the images, the TK package will still bring in a new one, and then your numbers might get off. So it's often a good idea to be able to restart your kernel. So close it, or if you're in idle, you have the text editor and the shell separately, just close the shell. Idle restarts every time anyway, so it's not as big a problem there. But you can see it's starting to have that standard appearance, traditional appearance of a GUI. Got a toolbar with the buttons up top, which I meant to make smaller. Let me go turn that sub sample back on. Because that's a really big button. But we don't need that big of a button. There we go. So subsample 2 means divide by 2. So we get buttons there. And that button just needs to call a function, which will do that. So that's not going to be any different from what we saw before. These keyboard bindings. But then on your homework, you'll just copy and paste that a lot. I'll do something better for the primary IO. So I'm going to finish the general layout real quick with one more widget. And I'm assuming y'all are probably going to spend some time doing this some stuff over the weekend. So I want to show this other thing. So my idea for the primary IO here since this is like a company payroll software, the companies are gonna know how many employees they have, right? So I was thinking is we can put in tabs. So employee 1, and then we'll have employee 2, employee 3 file. And then, well, for our simple case here, we have one text box for an input, input hours, except for the manager employee, because then we don't need to input the hours. The manager's on salary, so the manager would only need to input hours not worked, sick days. That's how salaries usually work. And a label for the output of work. Or list box, that might look better. Then I'll do a list box that has a net, taxes, and gross. Because we'll have the net pay along the way, so we can just fit that back. We'll create a list. Find the net pay, slight modification on our thing. Or some sort of output. That's not going to happen to the next class, so I'll move it for now. I'll put a label, I'll draw a label and just output the gross. Keep our example simple. That's what I had in mind because I wanted to look at something specific. Did anybody have any ideas on something that might make a good input output for this? We could change instead. Okay, I assume the silence means no. So the reason part of the reason I wanted to do this is because if you just went to guess, you would probably guess the wrong name for how we put those tabs together. The tab is only the label. So that word's on there. But then where do we put a bunch of them together like that? And that was actually an update to the original TK interface package. So it came around 11, 12 years later, something like that. The original TK's early 90s. And the early 2000s, it was updated with some more stuff. But to do the update, they just added it in another folder. So this is a folder that we're looking in. We're going to bring in all the stuff in the folder. And that folder is full of scripts. If you go to where your Python language is installed, you can find that and look at the objects making that and see what it's like. But there's another folder in there that has updates, and we just added another K. So it's called TTK. It's TTK. So just add another T on for some updated stuff, more modern looking buttons. A few things are more modern, look a little bit better than the early or than the original versions, and a few extra things, including what we need to make this, which is notebooks. An example I meant to pull up because I haven't used one in TK in a while, but I forgot to do that. So let's see if I remember it. Well, actually, no, I'm going to pull up the example because we've already been at this a while. And this is the last thing for this evening. I'm sure you all are probably ready to stop listening and start doing stuff. So I'm going to pull up the example so I don't waste time seeing if I can do this from memory. I'll try to something like that at the beginning of class, not at the end. Oh, I probably would have guessed correctly. So stuff for the primary input output area. So inside of that, first thing I want is the thing that holds all of these different tabs. And that's a notebook. I'll call it NB main. So the main notebook. And it's not available in the original package, so we do have to do TTK, the secondary package, .notebook. And initializing the stuff from the second package, it was intended to be an extension on the original, so it mostly follows suit. Everything in the second package takes cascading style sheets by default. So those who have seen how to do layouts with CSS, the TTK package, all that stuff takes CSS. And then the original stuff, you have to do a slight modification to apply CSS to get all the colors and stuff. That's a very common thing since HTML5 does have a standard for how we set appearances, but nothing else has a standard for how we set appearances. Everything else just went ahead and started using the one that is an official standard somewhere. That way there's consistency across what we do as programmers. We're gonna have to keep learning different things. It's like, oh, there's a standard for layouts. Let's use that over here too. And then we don't have to learn something new over and over and over again. So those who know cascading style sheets to put together style rules, that's how you style everything in the TTK stuff. And then the original TTK stuff, you have to make a slight modification for CSS to work. So most people do the original stuff like in the background, the frames, and then do the newer stuff that needs style on top of it. So where's this going? This is going to go in our primary IO container. Actually, I'm going to make this the primary IO. I'm going to get rid of that and call this. I'm going to make the notebook our primary IO because the notebook is a container. It's more like a folder that the tabs go in. And y'all, I don't have one. Y'all know those accordion folders that are full of tab, the little tab slots that we stretch out and put things in. I don't think there's one in the room here. I don't see one in here anywhere. I'm sure everybody's seen them, right? They collapse and we expand them. That's kind of the idea of a notebook. So it's a frame. Don't really need to put it in another frame. But then we need our tabs for it. So I'm going to use the names of our employees. Oh, I already used TB. Oh, tab short. So I'm just going to use the word tab as the Hungarian notation prefix. It doesn't have to be an abbreviation. It can be the whole word. So like tab Bob. And then we'll do Bob's payroll stuff on one tab. And whatever those names were, I think they're up here. Bob, Sally, and Becky. So we'll have a tab Bob. There's going to be a TTK.frame. I think we could use either frame, but since we're going to put this in a notebook, I always like to use the TTK frames instead of the original TK frames. The TTK frame, and it's going to go in IO primary. The primary input out area. Put the text here. I don't think I do. No, I don't. I would have guessed something wrong if I did this off memory. Yeah, so we just need to say where it's going to go, and then we add it to the notebook. So our primary input output, which is a notebook, has a .add method, and we want to say what tab we want to add. So tab Bob, and then what's the little label on that going to say? With text equal to text equal Bob. And we don't have to pack or grid though do a packer grade, we don't have to do any of the placement for that because we added it explicitly to the notebook. So we just have to use pack or grid or place to get the notebook on there. And then all that stuff has already been added to the notebook. In this case, just one, but the other two will be very, very quick. Uh-oh. Did I spell it wrong? I was gonna do this. Pack. I'm going to call it NB main. Oh, that's why. I'm gonna put it in itself. Well, this is probably a better name anyway, the main notebook. Now that we know what the primary input output is going to be, a notebook full of tabs. So then when we pack that, we need to pack in that main. So, I did, sorry, change my mind there at the last second. It's a notebook, and primary input output is a generic term. So now that I know specifically what it is, I'm going to give it a useful name. Our main notebook is the TTK notebook. It goes right into the GUI, the root element of our tree. Then we create a frame that goes into it. And then instead of packing or gridding or placing the frame, we use the notebook to add that tab explicitly. Say what the frame is, and then what you want the little label to say. Let's see if it runs this time. Oh, I still got IO primary somewhere. Where's that still typed at? Oh, down here. Well, this time. Oh yeah, these need to go in that. So now we'll have the input. Those labels are going to change, but instead of going to the primary IO, they need to go on that tab. What would I call it? Oh, tab Bob. Oops. So now they're going to go into that notebook with the grid instead of the whole background. Hopefully that makes sense. I'll give you a second to think about it. All the rules for how those get put into a grid are the same. Well, all I did there, hopefully if you're following along, what I did is just change what the parent container is. Same rules, just a different place. Let's try this again. Oh, no error messages that time. There we go. So you can see the Bob one is there. There's some labels, an input label, some numbers, and probably gonna have to come back and change how that calls. But I can quickly do that copy and paste thing now. I'm going to reorganize this. So this label goes with this tab. So I'm going to move those up next to that tab where I created it. Just keep things organized, and this will be I'll call it label Bob. Oh, I'm going to put my cursor here, and in my IDE, it's Control R for find and replace. So we don't have to worry about tabs. So if you select that word, it's usually Control R or Control H. Control H is the traditional one when they first developed, and then Control C, Control V. The common ones say Control H, but over the years that's kind of gotten replaced by Control R in some places to find a word and replace it with, say, LBL Bob. So the label for the Bob tab. Then we can replace all of them at once. Everywhere in the code. So I probably would have missed one because the focus went all the way to the top. So I'll do the same thing here. TXT Bob. Oh, whoops. So I'll select this, hit Control R, and find that and replace it with TXT Bob everywhere, and just hit the replace all. There we go. So now those labels are specific to Bob. So that's the input for Bob's hours. And we're going to run out of time. Well, we're pretty much out of time. But then a label, which will obviously change here very soon. There's something else going on. Okay, my graphics are starting to act weird. I don't see it going through the camera though, so it must be my local screen. Oh, so now we need a couple more tabs. So the tedious repetitive part, we'll copy that, make a tab for Sally, and then make a tab for Becky, and just go through here and change each one of those explicitly. Oops. So what is this? Tab Sally goes in the same place. LBL Sally, TXT Sally, tab Sally, tab Sally, and then add tab Sally to that. And then come down here, copy that, and do the same thing for that label Sally, and text for Sally. And that's the process you're doing when doing homework. Make it work on the first one, do all the testing, and after that, just copy, make as many copies as you need, and then make the small changes. So like tab Becky will contain the label Becky and the text Becky. And get loaded into tab Becky and get loaded into tab Becky. Oh, change the text that goes on it. Change that. Might as well change this while I'm at. Oh, yeah. Oops. Our instructions are now going to be enter Bob's hours. Or enter Sally's hours. Or enter Becky's hours. So you can see it's a very repetitive process. Once we get the work done, there's a lot of doing the same thing over and over again. What's left? Label Becky and text Becky. Because we don't have to use grid for the actual tab, but the stuff that goes in that tab still needs the layout for the tab. I think I got everything. Let's check. No errors. Oh, there we go. So the first one, we'll just enter Bob's hours and then type in Bob's hours, hit the enter key, and we'll see his gross pay there right now. So probably not in the next 7 minutes. Then we can click the Sally tab. Same thing, enter Sally's hours, type in how many hours she has, hit enter. Or type in how many hours she has and click the button or the menu. or eventually a right click. Or maybe Control G as a keyboard shortcut, but we'll see a couple more things on Tuesday. Hopefully that's making sense how it flows, the general flow, and then from that it's copy and paste and call the method. We'll see some of that on Tuesday, look at some more widgets that we have to work with. I think we've seen most of the major components now, well, we still need to make this work. So we need to call the method from all the different things we put together. So now the layout works, we need to have them all do something. Well, our payroll button did do something, but it doesn't do it anymore. So we need to make those buttons. Now we need to make those buttons all call the same method. But hopefully you see that the general layout is very repetitive. Let's see, /delete. Going to get stuff. All right, so git add dot git commit dash m for message. We'll leave this a message of a second day with TK. Then we can git push origin main. All right, so it's back online. So if you want to grab those examples, it's on the repository for the class. I believe the link for it's on the homepage of Ivy Learn, so you can quickly find that. That's why I've been putting all the examples there. Does anybody have any questions about that stuff tonight? Look at that manifest, and hopefully that makes sense why I included that instruction. And hopefully you see that that's a very, very easy thing. For the most part, it's an empty text file. You just have to give it a very specific name, because in the Python programming language itself, it is hard coded into open requirements.txt for in read mode. So that is hard coded into the Python programming language. It has to be that name, but it can be an empty file. So please include that. Hopefully it's a really easy step, and it is critical once we finish our software and once we release our software to the public. So because installers will all installers will need a manifest. Any questions? Okay, I assume the silence means no questions. So y'all have a great weekend. If you have any questions, let me know. I don't have any big plans for the weekend, so I can probably answer your questions very, very quickly over the next couple days. I will see you all on Tuesday next week. Y'all have a good one.